Hey guys, so today we are going to take some notes on adding and subtracting fractions. So the first thing we need to take a look at is a fraction. So we have right here this fraction, and we need to be able to know some things about it. So right here, this 1 is actually called our numerator. So we never refer to this right here as the number on the top. We refer to this as our numerator. The number right here, this 2, is called our denominator. And this line that separates our numerator from our denominator is called our fraction bar. So the way we read this fraction, we read this as 1 over 2, so 1 over 2, or we could read this as 1/2. So fractions are parts of a whole. So we can look at this and we can see that this is not one whole, it's half of a whole. So how do we solve? How do we add or subtract a fraction? Here are some steps in order to be able to solve that. The first thing we have to do is find a common denominator. The second thing we have to do is write an equivalent fraction. The third thing we have to do is solve the problem. Something to keep in mind is equivalent. You'll hear me say that a lot. Equivalent just means equal. It's just a mathematical term for equal. So our first problem is 2/3 or 2 over 3 plus 1/5 or 1 over 5. So I first have to find a common denominator. So what's a number that 3 and 5 can both go into equally? Well, I'm looking at 15. I know that 3 can go into 15 and 5 can go into 15. So I'm going to rewrite this problem over 15. So what am I multiplying 3 by to turn it into 15? I'd multiply it by 5. What I do to my denominator, I have to do to my numerator. So 2 times 5 gives me 10. So I'm going to do the same thing to 1/5. I'm turning it into something over 15. So to figure out what that something is going to be, if I multiply 5 times something to get to 15, it would be a 3. So what I do to my denominator, I do to my numerator. 1 times 3 is 3. So now I just have to solve. I leave my denominator alone. It's going to just remain a 15. And now I just add my numerators. 10 plus 3 is 13. So my answer is 13 over 15. Now we're going to come over here. 5 and 2. A denominator that both 5 and 2 can go into is 10. To make 5 turn into 10, I would multiply it by 2. What I do to my denominator, I do to my numerator. 2 times 2 is 4. To turn 2 into 10, I'm going to multiply it by 5. What I do to my denominator, I do to my numerator. 1 times 5 is 5. So now I keep my denominator the same, and I'm going to add my numerators. 4 plus 5 is 9. Okay, 5/7 plus 1/2. I know that 7 and 2 both go into 14. To turn 7 into 14, I'm multiplying it by 2. So I have to do the same thing to my numerator. 5 times 2 is 10. To turn 2 into 14, I'm multiplying it by 7. What I do to my denominator, I do to my numerator. 1 times 7 is 7. So I'm going to leave my denominators alone, just bring it over. So 10 plus 7 is 17. So now we have something special here. We have something called an improper fraction. So I'm going to just bring that down here so you can watch something fancy happen. So 17 over 14. An improper fraction, you will see in just a minute, is when we have a numerator that is larger than our denominator. So we're going to turn that into a mixed number. And I'm going to ask myself, how many times can 14 go into 17? That is 1 time. 1 times 14 is 14. How many more gets me up to 17? Or like kind of a remainder. And that would be 3. We'll practice more of those in just a minute. Now we have a subtraction problem. 3/4 or 3 over 4 minus 1 over 3. So a common denominator for these would be 12. 4 times 3 gets me to 12. So what I do to my denominator, I'm doing to my numerator. 3 times 3 is 9. 3 times 4 is going to get me to 12. What I do to my denominator, I do to my numerator. 1 times 4 is 4. So then I'm going to subtract. 9 minus 4 gives me 5. And remember, our denominator stays the same. So moving along in our notes, we're going to talk about reducing fractions. This gets really important when you get into middle school. So a fraction is in simplest form when the only number that divides evenly into both the numerator and the denominator is 1. So that will make more sense as we do some examples. So the first example we have is 42 over 56. So you're looking for a number that will go into both our numerator and our denominator. So I find that most kids will just start with what they know. So I'm looking at both 42 and 56, so I know that they're both even. And when they're both even, I know that I can divide them both by a 2. So you have to divide both the numerator and the denominator by the same number. I can't do a 2 up here and like a 4 down here. It wouldn't be the same fraction. So we're looking for an equivalent fraction right here. Equivalent meaning it's the same or equal. So 42 divided by 2 gives me 21. 56 divided by 2 gives me 28. So now I have something a little bit more manageable. And I know that at 21 and 28, a 7 goes into both of those because I know my math facts, my multiplication math facts. So 21 divided by 7 is a 3. 28 divided by 7 is 4. That's as small as it goes. So I know that the only number I could divide 3 and 4 by is 1. So that's when it's in simplest form. So if I just pause right here, and if this is as far as I got, that is not simplest form. Now this is an equivalent fraction to this fraction. They are equivalent, but this is not simplest form because I could divide it by another number and get down even smaller. That's what it means by simplest form. All right, our next example is 112 over 120. Once again, I see that they're both even. Now, I could do a larger number, but this is what my kids feel most comfortable doing, and I'm making this video for them. So 112 divided by 2 gives me 56. 120 divided by 2 gives me 60. So I see, again, they're both even, so I could divide by 2 again. And there's nothing wrong with doing this. Now, could I have started off and divided by 4 or a larger number? Sure, but there's nothing wrong with just going by 2s if they're still even. So 56 divided by 2 gives me 28. 60 divided by 2 gives me 30. So guess what, guys? Once again, I see that these are both still even. So guess what I can do again? Divide by 2. 28 divided by 2 gives me 14. 30 divided by 2 gives me 15. So once I'm here, 14 over 15, the only number that I can divide both 14 and 15 by is 1. So that means I am at the simplest form. All right, our next two. So we have 24 over 76. I can divide it by 2 because I know that those are both even. 24 divided by 2 is 12. 76 divided by 2 is 38. And the reason I suggest starting with 2 is because 76 is not a number that I'm real familiar with. So if I know that I can divide these both by 2, might as well go ahead and start it. 12 and 38. 12 divided by 2, 6. 38 divided by 2 is 19. So something else I want to talk about is this number 19 is a prime number. That means the only numbers that you multiply together to get this number are 1 and 19. So I know that the only numbers that will go into both 6 and 19 are 1. So it's in simplest form. All right, 25 and 55. Uh-oh, I have a problem because these numbers are not even. So now I have to look for a different number that can go into both of those. Does that mean that it's already in simplest form? No, I have to just start to be creative. And I see that they both end in a 5. That means I can divide them both by 5. This is where knowing your divisibility rules will help you. So 25 divided by 5 is 5. 55 divided by 5 is 11. So that takes you to your simplest form. Now we're going to be working on improper fractions and mixed numbers and switching between the two. This is one of my favorite things to do. So an improper fraction is when the numerator is larger than the denominator. So a couple examples we have are 32 over 29 and 5 over 3. So the steps to change to a mixed number. The first thing we do is write your denominator. Because your denominator is not going to change. Next, number 2, it says to find your whole number, divide your numerator by your denominator. And these are like your official directions. You might hear me say something else when we're doing it. Step number 3, to find your numerator, it is your remainder. Okay, so here are our examples. So our first one says 14 over 5. So first things first, we're going to keep our denominator the same. And lots of times kids will forget to even write down their denominator, and that's the easiest part. All right, so now we're going to ask ourselves, how many times can 5 go into 14? So remember, you're dividing. This is going to be our whole number. Well, 5 can go into 14 2 times. Because 5 times 2 is 10. Well, how many more do we have up here? Like, how many would we have as a remainder? 4. Because we have 14, and 5 times 2 is only 10, but our number up here is a 14. Well, let's come over here. 40 over 7. Well, we know our denominator is a 7. Here it is. Nothing's changed. How many times can 7 go into 40? 5 times, because 7 times 5 is 35. How many more do we have till we get up here to 40? 5. 29 over 6. Our denominator stays the same. It's a 6. How many times can 6 go into 29? 4 times, because 6 times 4 is 24. How many more till we get up here to 29? 5 times. 5 numbers. Okay, last but not least, our denominator is a 3. We can do that without even thinking. How many times can 3 go into 31? 10 times, because 3 times 10 is 30, and we need one more number to get up there to 31. So here's where we get to go the other way. We're going from a mixed number to an improper fraction. And here are the steps in order to be able to solve it. First, you're going to write your denominator, just like last time. Then you're going to multiply your denominator by your whole number. And then step number 3, you're going to add your numerator. All right, so now we get to have some fun with our examples. First, write down that denominator, and I always like to write out some arrows here. So you're going to take this denominator, you're going to multiply here, and then you're going to add up here. So 7 times 2 is 14, plus our 3, we get 17. Over here, we know we're going to have 7 again. We're going to multiply here and add up here. So 7 times 7, 49, plus 6 is 55. Put our denominator of 5, 4 times 5, and then we're going to add. So 4 times 5 is 20, plus 1 is 21. Our 5 down here. 5 times 1 is 5, plus 3 is 8. Simple, right?